So today yet another LED retrofit for a tungsten lamp. And of course you can buy one. I already have one, but it's quite crappy. So why not build one? And a lot of people were saying why not use a bridge rectifier. So let's use a bridge rectifier today. And more LEDs in a series. In this case I don't have to actually match the size of the original lamp. I just have to fit it into this holder, which is quite large. So I can use a board which just fits into this cover. And basically put as many LEDs on it as I can. And this will go on to this. And this will go into the holder with the base from a tungsten lamp, which was bad. So I crushed the glass and the cement out of it, and then it can be all soldered together. I've made some cuts in it for this to be soldered on, and for the bridge rectifier here, and here for the LEDs. Now the LEDs are atrociously botched on it. Now this bit is ready. It will go into the tape. Now this board is in place and soldered into the tape. Now the boards are in place and joined. Let's solder some diodes for a bridge rectifier here. We have 4 diodes in place. And of course a resistor couldn't be missing. And now it's actually for 48 volts AC or DC in any polarity. But with an additional dropping resistor or capacitor it can be used for mains. And then with a capacitive dropper this resistor works as an in-rush resistor. The first test, 330 kilo ohm resistor in series. And it works nicely. Or a 47 nano capacitor in series. That's way brighter. Of course I have to clean the rosin from them. Using a phenol and a toothbrush, of course. Now it's nicely cleaned. Nice. Of course it could also get a yellow cover instead of a green one. Even brighter. But even the green one is bright enough if it's not under studio lights, definitely. Of course the brightness could be changed by changing the value of this capacitor. It draws about 3.3 milliamps from a mains. And it will go into one of these now legendary control boxes, which came in 1, 2 or 3 position versions. And could have various buttons installed in them, emergency stop buttons, as well as rotary switches, even key switches. But of course also indicators with the lamps originally in them. The original lamps were 2 watts and still kind of dim. This is much brighter and according to my watt meter only draws 130 milliwatts. This one will go into this single position box. You will take this button out and put the lamp into it. A quick test. Nice. And of course the capacitor gets a discharging resistor in parallel and there will be a fuse. That's the fuse, T32 milliamps. Some grommet and a strain relief and a fuse and the cable going to it. And that's it. And here it's being installed. The live and neutral, but also the aluminum box grounded. And here it's in place, mounted on the wall, with the cover on, in the off state, and now operating. It's connected to the boiler contactor, indicating it's heating water right now, and basically at the same time it indicates that the cheaper rate of electricity applies. And here's the super complex schematic of it. The live goes through the fuse, the capacitive dropper with the discharging resistor. Then there is a bridge rectifier, made of almost any diodes, at least 400 volts, at least 100 milliamps. The chain of 12 LEDs in a series, these ones, and the in-rush resistor, and that's it. This resistor limits the in-rush current when it turns on and this capacitor has to rapidly charge. So that's it, and if you like my videos, please consider subscribing, supporting my channel on Patreon or using the thanks button. And big thanks to all of you who already support me. And I plan to explore this failed gallium nitride charger 120 watts donated by a viewer.